Today's class we will be starting with some of the problems based on our fifth module. The first problem is going to be a lossy dielectric has an intrinsic impedance of 200 with an angle of 30 ohms at a particular radian frequency, that is omega. If at that frequency the plane wave propagating through the electric dielectric has the magnetic field component, that is here it is given as H is going to be equals to 10 e raised to minus alpha x cos omega t minus 1 by 2 x of ay. This is a given question. From this, we have to find out what is our electric field intensity and also what is the value of our alpha. Then the given wave travels in AX direction. From this, it's going to be a giving. Then so that the AK is going to be equals to the AX and AH is here it's already given, that is about AY direction. Therefore, minus AE is going to be our electric field intensity signal, that is going to be equals to AK with AY, that is AH, or else I can write here as AX cross product with the AX with AY, that is going to be equals to AZ. Therefore, we can write here as AE is going to be equals to the minus AZ. Z means it is giving the information about our electric field intensity is moving along the Z direction. Opposite of that means is this is a minus of Z direction. This is our Y. This will be our X. Therefore, then from based on the equation, what it is given, from the equation, if we compare with the standard equation where H naught is going to be equals to 10, because here the amplitude is of 10 only. Therefore, E naught by H naught is nothing but eta naught from the basic theory what we'll already taken, right? Therefore, that is eta is nothing but what is the given intrinsic impedance? It's given as 200. That is 200 into with an angle of 30 degrees. That I can write here as 200 e raised to j pi by 6. Cos pi by 6 and sin pi by 6 is nothing but 30 degree. For that reason, based on that, I can write here the 30 degree as e raised to j pi by 6. This is nothing but our E naught value, that is going to be equals to, if I take this H naught is 10, if I substitute here, then 10 into 200, it's going to be 2000 into e raised to j pi by 6. Then except for amplitude and phase difference, E and H always have the same form. Therefore, I can write the electric field intensity as E is equals to real part of 2000 into e raised to j pi by 6 e raised to minus gamma x e raised to j omega t AE. Then this is not, you can write this equation, it will be somewhat confusing. I will prefer to write this equation, it will be easy for us. That equation is going to be E is equals to minus 2 e raised to minus alpha x cos omega t minus x by 2, that is your beta, plus pi by 6 into AZ. Here instead of 2000, here it is taken as K, kilovolts per meter. Then knowing that the beta values of what here 1 by 2 only, if I compare with the equation, then beta is going to be 1 by 2. We need to determine the alpha value. To find out the alpha value, what is the equation we already learned? That is alpha is going to be equals to omega square root of mu f long divided by 2 into square root of 1 plus sigma divided by omega f long, that square minus 1. This is the alpha equation, and beta equation is going to be, instead of minus, it is going to be changing here as a plus. That's it. Then alpha by beta is going to be equals to, when I do here, this whole part will be, if I divide the whole, then this will be going cancel. Next we left with the inner part only. Therefore, square root of 1 plus sigma divided by omega c square minus 1 divided by 1 plus sigma by omega epsilon the square plus 1, that power raised to 1 by 2 you will be left in here. Therefore, but the sigma by omega c omega epsilon is equals to tan 2 theta t theta eta. Therefore, here it is going to be angle is already it's given as 30 degree only, right? The same thing you have to consider here. That is 2 into 30, 60. That is nothing but tan 60 is a root 3 value. Hence, if you substitute here, you'll be getting as alpha by beta is going to be 2 minus 1 divided by 2 plus 1 power 1 by 2. That is nothing but 1 by square root of 3. Therefore, alpha is going to be equals to beta divided by square root of 3. Beta is nothing but 1 by 2. 1 by 2, 2 into square root of 3 is nothing but 0.2887 Napiers per meter you will be getting out. This is what the equation in terms of electric field and also to the alpha value. That one type of problem based on in the exam, they may ask any different numericals and you have to find. You can they may ask for finding of H and also with alpha and also with beta. Here it is given as finding of E and also with the alpha. And next problem is in a lossless dielectric for which the eta is given here, that is 60 pi, and mu r is given as 1, and H is given as minus 0.1 cos omega t minus z ax plus 0.5 sin omega t minus z ay amperes per meter. That is calculate F-long r and also omega and also of the electric field intensity. In lossless dielectric medium, in this case, you have to remember what is our sigma value. Sigma is always going to be 0 and alpha is also going to be 0 and beta is going to be equals to 1. Therefore, eta is going to be equals to square root of mu divided by F-long r. F-long, that is nothing but square root of mu r divided by F-long r. F-long r, you can write that. Then that is going to be equals to, when I substitute for these two values and also with F-long r is given as 1, then I can get the equation as 120 pi divided by square root of F-long r. We don't know that we have to calculate what is that F-long r. In the medium, what is the equation for F-long r? Therefore, square root of F-long r is going to be 120 divided by eta. Here already given the eta value, that is 65. Substitute here, we'll be getting as 2. Therefore, F-long r is nothing but 4. Then beta is going to be equals to omega into square root of mu F-long, that is nothing but mu square root of, again mu naught F-long naught, square root of mu r F-long r, that is nothing but mu divided by c. These are all things we already learned in the theory part. For that reason, directly you can write it as omega by c into square root of 4 F-long r, that is nothing but 2 omega divided by c. Omega is nothing but beta c divided by 2. Therefore, beta is 1. Just you substitute here 1 into speed of light is 3 into 10 raised to 8 divided by 2. That is nothing but 1.5 into 10 raised to 8 radians per second. From the given H and E field, here H field, E can be calculated in two ways. We want to calculate what is our E. Here it is given as H given. There are two ways we can find out. The first way by using the techniques based on a Maxwell's equation developed in this chapter, or else by using of the Maxwell's equation what we have used in the previous cases. The method one is going to be to use the techniques developed in the present chapter. The H is going to be equals to H1 plus H2. In this case, it's given two factors for that reason, where H1 is going to be first factor is of minus 0.1 cos omega t minus z into AX, and H2 is going to be 0.5 sin omega t minus z into AY, and the corresponding electric field is also going to be it is also having two terms, that is about E is equals to E1 and E2. in the standard form, what it's going to be, that is where E1 is going to be E10 cos omega t minus z into AE1, and A2 is going to be E20 sin omega t minus z AE2. Then notice that although the H has components along AX and AY, it has no component along the direction of the propagation. It is therefore the TEM wave. This is, or what is this TEM wave? We already come across. Therefore, for electric field, the first part, that is E1 is going to be, AE1 is going to be minus AK into AH1. That is nothing but minus AZ cross minus of AX, that is giving in the direction of AY. Therefore, E10 is going to be equals to eta times H of 10. That is nothing but 60 pi 0.1. That is, if you calculate this, you will be getting as 6 pi. Therefore, the E1 equation is going to be 6 pi cos omega t minus z in the y direction. For in the same way, for E2 is going to be AE2 minus AK with the AH2. That is nothing but in the minus AZ cross with minus AY. That is gives, that is AX. Therefore, E20 is going to be equals to eta times H20. Eta is already known, that is about 60 pi, and H20 is already given, that is 0.5. Substitute here, it will be as 30 pi. Therefore, E2 is going to be equals to 30 pi sine omega t minus z into AX. Then adding two equations, then you will be getting, that is E is going to be equals to, just return the equation of E1 plus with E2. That is, you'll be getting as 30 pi is nothing but 94.25 sine omega value, what we already got, that value you have to substitute here, 1.5 into 10 raised to 8 into t minus z into AX plus 60 pi, 6 pi is nothing but 18.85 cos omega 1.8 into 10 raised to 8, 1.5 into 10 raised to 8 t minus z into AY volts per meter. This is one method. The another method is a Maxwell's equation. You see here, that is del cross H is going to be equals to sigma is sigma E plus epsilon dou E by divided by dou T. But because of lossless medium, conductivity will be 0. For that reason, E is going to be equals to 1 by epsilon integration with del cross H into dt. Therefore, del cross H into dt is going to be AX, AY, AZ, dou by dou X, dou by dou Y, dou by dou Z, HX, then of HY, because in the given equation, it is varying across X and Y only. For that reason, here it is going to be HXZ, HYZ, and it will be 0 only. That is nothing but as usual method of determinant of matrix. Then we'll be getting as minus dou y HY divided by dou Z of AX plus dou HX divided by dou Z of AY. Then we'll be substituting now what is HY and HX. Then H20, that is y direction, cos omega t minus Z AX plus H10 sin omega t minus Z AY direction. Then H10 is 0.1 and H20 is 0.5. Then substitute here, E is going to be equal to 1 by epsilon integration del cross H of dt. Then you will be getting as H20 divided by, just you have to integrate here of this equation. Then H20 divided by epsilon mu sin omega t minus Z AX minus H10 divided by omega epsilon omega cos omega t minus Z AY. Just you substitute for epsilon and omega. We already got the values for epsilon and also epsilon r. Just you substitute and then substitute for H0, H20 and H10. You'll be getting as the same equation what we got in the first method. Which one is easy for you? You can choose that method and you can solve that problem. Next problem is of a uniform plane wave propagating in a medium has E is going to be equals to 2 e raised to minus alpha z sine 10 raised to 8 t minus beta z into ay volts per meter. If the medium is characterized as f long r, they only given that is 1, f long mu r is given as 20 and sigma is given as 3 specimen per meter, then find alpha, beta and also h. We need to determine the solution is going to be the loss tangent to be able to tell whether the medium is a lossy dielectric or a good conductor. First, you have to find what is this giving for us. Therefore, sigma y omega c omega f long, that is going to be equals to, they are already given, just you substitute here 3 divided by 10 raised to 8 into 1 into 10 raised to minus 9 divided by 36 pi. Then you will be getting as it is more value. Therefore, 3393, it is which is greater than 1. From this, it's showing that the medium be regarded as a good conductor at a frequency of the operation. Hence, alpha is going to be equals to beta, that is nothing but square root of mu omega sigma divided by 2. Just you substitute for omega 4 pi 10 raised to minus 7 into 20 10 raised to 8 into 3 divided by 2. Given values, you just substitute here. Power 1 by 2. Then if you calculate, you will be getting as 61.4. Then alpha is going to be equals to 61.4 Nepers per meter and beta also going to be 61.4 radians per meter. Then mod of eta is going to be square root of mu omega divided by sigma, that is nothing but 4 pi into 10 raised to minus 7 omega is 10 raised to 8 only. What is given? Just we are writing it. 20 into 10 raised to 8 divided by sigma is given already 3 power 1 by 2. Then if you calculate, you'll be getting a square root of 800 pi divided by 3. That is tan 2 theta eta is going to be sigma divided by omega f long. That is nothing but we already calculated the value here. Just you substitute here. Then after calculating this, you will be getting as theta. Eta is going to be 45 degrees. That is nothing but pi by 4 only. From that, we can write the equation as h is going to be h naught e raised to minus alpha z sine omega t minus beta z minus pi by 4. What is it is given? That is ah. Ah is going to be ak into ae. That is nothing but ak is in terms of z direction and ae in terms of y direction. The remaining is of ax direction, that is in terms of minus. And h naught is going to be equals to e naught divided by mod of eta, that is nothing but 2 into square root of 3 divided by 800 pi. Then you will be getting as 69.1 into 10 raised to minus 3. Just you substitute all the values in the h equation. Therefore, h naught is going to be minus 69.1 e raised to minus 61.4 z sine 10 raised to 8 into t minus 61.42 z minus pi by 4 into ax milli amperes per meter. This is what a magnetic field intensity from the electric field intensity. Next problem, here it is given a plane wave E is equals to E naught cos omega t minus beta z into ax is incident on a good conductor that at az is greater than or equal to 0. Find the current density in the conductor. It's like a small derivation part. Since the current density J is going to be equal to sigma of E, then we expect J to satisfy the equation of 10.7. This is the equation of E. That is, it's going to be del square Js minus gamma square Js is going to be equals to 0. Then the incident, that is E, has only the x component and varies with the z. Hence, J is going to be Jx of z of gamma t into ax, and the equation is going to be changing as d square divided by dz square Jsx minus gamma square Jsx, that is going to be equals to 0. Then alternate differential equation with solution, that's going to be equals to Jsx is going to be equals to a e raised to gamma z minus gamma z plus b e raised to plus gamma z. Then constant b, this must be 0 because JSX is finite at Z is as it is going to be infinite. But in a good conductor, sigma is much greater than about omega f log. So alpha is equals to beta is going to be equals to 1 by delta. Hence, gamma is going, we know this, that is alpha plus j beta, that is nothing but alpha 1 plus j, that is nothing but 1 plus j divided by delta. Just to substitute here, Jsx is x is going to be equals to a e raised to minus z 1 plus j divided by delta. Therefore, Jsx is going to be equals to Jsx of 0 e raised to minus z 1 plus j divided by delta, where Jsx 0 is the current density on the conductor surface with z is equals to 0. Here is a small derivation part. Next question, for the copper coaxial cable, the figure will be like this. That's what we taken here, where this is of this is A like that. Let A is going to be equals 2 mm and B is going to be 6 mm and T is going to be 1 mm. Calculate the resistance of a 2 meter length of the cable at a DC and at a 100 megahertz of frequency. Then let R is going to be equals to R naught plus Ri, where R naught and Ri are resistance of inner and of outer conductors. Therefore, at DC, we come across the equation of this. That is, Ri is going to be L divided by sigma of S. That is nothing but L divided by sigma pi A square. What is the area of surface? That is, you have to write here. That is equals to 2 meters length. That is 2 divided by sigma. It's sigma value is going to be, that is 5.8 into 10 raised to 7 pi. Then 2, A is given as 2, 10 raised to minus 3 square. Then the equation is going to be 2.744 milli ohms. Then R naught is going to be L divided by sigma S. In this case, it's going to be changing as L divided by sigma pi B plus T whole square minus B square. That is nothing but L divided by sigma pi T square plus 2 beta BT. Then you substitute for the conductivity of the copper coaxial cable. That is going to be 5.8 10 raised to 7 pi over T is 1 plus 2 into 6, that is 12 into 10 raised to minus 6. Then you'll be getting as 0.8429 milli ohms. Then RDC is going to be total of those two, that is 2.1744 plus 0.8429, that is going to be equals to 3.587 milli ohms. Then at frequency 100 megahertz, our Ri is going to be Rs divided by Rs into L divided by width, that is it's going to be L divided by sigma delta 2 pi A, that is nothing but L divided by 2 pi A square root of pi F U sigma divided by sigma. Just to substitute for the values here, then eliminating as Ri is going to be 0.41 ohm. Since delta is going to be equals to 1 divided by square root of pi F mu into sigma, that is it equals to, when you substitute here, you'll get 6.6 mu 10 raised to minus 6 meters, which is less than T, that is equal to 1 millimeters. Then W is going to be 2 pi B for the outer conductors. Therefore, R naught is going to be equals to Rs L divided by W, that is L divided by 2 pi B square root of pi F U mu divided by sigma. Then substitute for each of values, then repeating as R naught as 0.1384 ohms. Then RAC is going to be equals to, just you add here 0.41 plus 0.1384, then you'll be getting as 0.5484 ohms, which is about 150 times greater than the RDC of this equation. Thus, for the same effective current I, the ohmic loss, that is I square into R of the cable at 100 megahertz is greater than the DC power loss by a factor of 150. This is what the conclusion we may graph for this.